Welcome back to the Deep Dive. We're here to cut through the noise, get you those insights you need from, well, some really incredible source material. And today, we're doing something a little different, maybe a bit more melodic. That's right. We're diving into a whole album, actually, an album of AI concepts and, the big challenges researchers are facing, but brought to life through music. It's called Data, Drift, and Destiny. Honestly, it's a really unique way to look at AI model development. So today, we're going to unpack 5 key tracks. Think of it like a roadmap, right? Exploring the highs, the lows, and often the really frustrating parts of building these intelligent systems. We'll be listening metaphorically, of course, to cycle we're in, then ephemeral IDs, shifting sands. My experiment broke the site. One sounds ominous. Then one more table, and finally, selection bias. These aren't just catchy titles. They're like powerful metaphors. They really capture the gritty, real-world struggles AI developers and data scientists deal with every single day. Our mission: distill the core challenges from each track, give you a shortcut to understanding the deeper implications.
Especially if you're invested in where AI is heading.
Indeed. And what's really fascinating, I think, is how these songs manage to synthesize these key themes, these aspirations, right from the front lines of AI development. They really highlight that tricky balance, between the tech execution, the human side of things, and just that relentless push for AI solutions that are impactful, reliable. It's like each track is its own kind of briefing document. It captures a specific challenge, often a pretty painful one, in this field that's just moving so incredibly fast. So you're getting this unique kind of emotionally resonant angle on that complex dance between data and algorithms.
Okay, so let's dive into this first track. It's called Cycle We're In. And I mean, the title alone, right? It just suggests this continuous thing, almost inescapable. The lyrics really drive that home too. They paint this picture of an endless loop talking about tangled threads in a digital stream. Your input stream, my output screen, rewritten codes, I lose my place, familiar patterns I can't retrace. And then that line that probably hits home for a lot of folks listening: you shift, I break, we start again.
Yeah.
It just perfectly captures that constant churn, doesn't it?
Yeah, it absolutely nails that iterative process in AI development. It's something we see highlighted in the source materials, definitely. But it's more than just, adjustment and iteration. This song, it gets at the real tension underneath it all. Developers are like constantly trying to make the model better, but every little change, new input, different environment, even a tiny code fix it can just set off this whole cascade.
Like a domino effect.
Exactly. It's exactly that feeling the song captures. Building, testing, it breaks, you rebuild, and asking, where does it even start? Where does it end? And look, this loop is crucial. You need it for progress. But man, it's also a huge source of technical debt and honestly burnout for the engineers. All that constant retraining, revalidating, monitoring, it just eats up resources. It feels relentless sometimes.
It really does sound like trying to hit a moving target. You get something working right, something stable, effective. But then the world shifts, or the data shifts, and bam, you're back at square one, troubleshooting again. You're, like the song says, relearning a dance of chance, binary steps in a fleeting trail.
Mm-hmm.
So beyond just fixing the immediate problem, what's the hardest part of managing this cycle? Is it the technical side or just the sheer drain on resources?
Well, it's often both, but I'd say primarily the hidden costs. For our audience, folks who follow this stuff closely, we know it's not just debugging. It's that technical debt that keeps piling up with every patch. It's the complexity of A/B testing when your baseline itself keeps moving, and just the huge operational burden of keeping these models live in production. Think about model decay, for instance.
Right. Where it just gets worse over time.
Precisely. A model can be perfect today, but if you don't keep updating it to match how the data is evolving, its performance will drop off, even if you haven't touched the code.
Yeah.
So this cycle, it's a necessary evil, really. But managing it efficiently, with solid MLOps practices, that becomes absolutely critical. Things like automated retraining pipelines, version control for your data sets, basically anything to avoid total chaos.
That makes a lot of sense. And that struggle for stability when things are changing internally kind of leads us nicely into the next track. Ephemeral IDs, shifting sands. The title itself just sounds, well, haunting, like you're trying to grasp smoke. The lyrics paint this really vivid picture. Words dissolve like whispers in hand. It feels like shifting sand. Numbers dance. They won't stay still. Chasing ghosts, our words are dead, out of vocabulary, left unsaid. You can almost feel that frustration.
Oh, absolutely. This track speaks directly to that huge challenge of data drift, and specifically that really thorny problem of ephemeral IDs in real-world systems. The core issue is data is never static, right? User behavior changes, language evolves, and crucially, identifiers you relied on suddenly vanish or they mean something completely different.
Like what kind of identifiers?
Think about product codes, SICUs that get discontinued, or maybe temporary session IDs from a website visit, even just how people use language. A word means one thing today, tomorrow it's slang for something else. These ephemeral IDs are a massive problem because they break the lengths your model uses to learn. It can't recognize past patterns if the identifiers keep changing, like the song asks, can you pin the fleeting skies, hold the stars in stable ties? It's questioning if stability is even possible sometimes.
Yeah.
Our sources clearly state this data drift makes it hard to maintain model performance and catch the meaning. So your model gets trained on a nice, stable snapshot of the world. But then it faces this shifting sand in reality. Items are out of vocabulary, the IDs are transient, and the model just struggles to adapt, to predict reliably. And we're talking about two main types of drift here. There's covariate shift, that's when the input data distribution changes. And then there's concept drift, where the actual relationship between the inputs and outputs changes. That one's particularly tricky.
Why is that?
Because the model's fundamental understanding of the problem becomes outdated. Imagine a fraud detection model. It's trained on old fraud patterns. If new types of fraud emerge with different characteristics, different ephemeral IDs of suspicious activity, the model might completely miss them.
Okay, this is where it gets really interesting, especially for something practical, like, say, a recommendation system. If the items you recommend or the user IDs themselves are constantly changing, maybe products get delisted or user accounts get merged, how does the model learn stable preferences? It really is like trying to build that sandcastle while the tide's coming in, washing away the foundations, and maybe the sand itself is changing type too. So what do companies actually do about this, beyond just constantly retraining?
That's a great question. And yeah, it's a huge focus in MLOps machine learning operations. Retraining is mostly reactive, so companies are investing more in proactive strategies now.
Yeah.
Things like really robust data validation when the data first comes in, setting up canonical ID systems, ways to create stable IDs from the temporary ones, using feature stores, which help manage and version features over time, and having advanced monitoring specifically designed to detect different kinds of drift.
So you can catch it earlier.
Exactly. Anomaly detection on the incoming data streams can flag shifts before they tank your model's performance. The goal is really to build models that are just more resilient to begin with, maybe train them on more diverse data or even intentionally noisy data, or use adaptive learning techniques. It's about accepting that real-world data is messy and transient and building systems that can cope instead of just hoping it stays the same.
Okay, now for a track that probably gives every AI developer listening a bit of a chill, my experiment broke the site. You can just feel the raw emotion in this one, that sheer panic. Stomach drops like a roller ride. Heart can't hold. It opens wide. Metrics tanked. Users out the door. It's like the absolute worst-case scenario playing out live.
Oh, absolutely. It vividly describes one of the biggest fears during that whole deployment and monitoring phase. The source materials highlight this specifically, that major fear of breaking the site. It's not some theoretical risk you write down in a doc. It's the harsh reality where, boom, metrics tanked, users out the door. The impact is immediate, it's widespread, it's very, very visible, and it hits everything: revenue, user trust, the brand's reputation. It's that awful sinking feeling knowing your code just caused chaos.
Yeah, you can really feel that.
And the desperation in the lyrics captures it perfectly. Fingers tap, the screen's aglow, sweat drip fast, the cold will flow, I'll decode the tangled night. That's the frantic, high-stakes debugging reality. Deploying AI isn't just about technical success in a lab. It's about protecting the user experience, the business operations, honestly, the reputation of the whole engineering team. The pressure is just immense. This track really gets that human side of the pressure and why having solid release management is so crucial.
You really can feel that dread, can't you? It's the ultimate test, taking a model from that controlled lab environment into the wild, unpredictable world of live users. And sometimes, yeah, it fails spectacularly, with immediate, very public consequences. So what are the actual, maybe more advanced strategies companies use to lower that risk? How do you balance letting teams innovate with preventing these kinds of disasters?
That really comes down to smart release strategies and really robust observability. You don't just flip a switch on a new model for everyone. Teams use techniques like canary deployments. You roll out the new model to just a tiny fraction of users first, maybe 1% or 5%.
Right.
You watch it closely. If everything looks good, you gradually increase the percentage. A/B testing is key here too, comparing the new model against the old one. Sometimes that's combined with dark launches. The new model runs in the background, processing real traffic, but its results aren't actually shown to users yet.
Ah, so you can see how it performs without any risk.
Exactly. You monitor its performance, its predictions, without impacting anyone. And then, if something does go wrong during any of these phases, you need sophisticated observability tools. Real-time dashboards, automatic anomaly detection, and crucially, the ability to roll back to the previous version almost instantly. The goal is super rapid detection and recovery, and fostering innovation while managing risk. That often involves building what they call a blameless culture around incidents. Focus on fixing the system, not blaming individuals. That way, engineers feel safer experimenting, knowing there are guardrails in place.
Right, that makes sense. Okay, next up, one more table. This one speaks to a frustration I think many people in data engineering or model building know all too well. It seems like a small thing, but it can cause major headaches, major delays. The song goes, experiment done, my model's a star, but here we go, tweaking it, raising the bar. If revision it groans, it cries. Is it worth all the tries, or just one more table, one more line chasing perfection, a border undefined, one more tweak, a tiny request? It just nails that feeling of never being done.
It perfectly illustrates what the sources call the schema evolution challenge. It's a persistent headache, honestly. It's always that one more column or one more table request. Seems small, right? But it can totally disrupt workflows and force reruns across your entire data pipeline. Even when a model is doing great, that drive for perfection, adding a new feature, getting more granular data, integrating some new source, it leads to these constant incremental changes to the data structure, the schema.
That's complicated.
It can be hugely complicated.
Right.
Just
Yeah.
adding one new field or changing a data type. That can ripple through the whole ETL process, extract, transform, load. It means potentially rewriting code, revalidating everything, maybe breaking downstream dashboards, or even other models that relied on the old structure. It's often way more work than it looks.
Ah.
And the song really highlights the true cost. All the hours we burn, the coffee we train. This isn't just a quick add-on. It often means diving deep back into the fundamental data infrastructure. It can cause unexpected problems, force model retraining, and delay other important work. It's that constant tension, isn't it, between agile development, wanting to iterate fast, and needing the stability for a production system people depend on. Managing this often involves things like better data governance, versioning your schemas, maybe using those feature stores we mentioned earlier to abstract away some of that raw table complexity. Because yeah, the hidden complexity behind a tiny request can be absolutely staggering in a big system.
So what does that mean for the people actually doing the work? It sounds like this constant negotiation. You've got a data scientist who sees maybe a tiny potential model improvement with one new feature, and then the data engineer knows that one more table could mean weeks of replumbing the entire data pipeline. Every tiny request, every one more tweak sends you off chasing perfection again. It sounds borderline divine in ambition, but maybe maddening in practice. Is it ever really done?
That's a really profound question. And for a living, breathing AI system, the answer is often, well, no. It's pretty much ongoing. I think the key insight here is learning to differentiate. What are the essential changes, the ones that actually deliver significant business value, versus the incremental tweaks that give you diminishing returns but come at a really high cost in terms of engineering effort and risk? Things that help are clearer data contracts between teams, really rigorously assessing the ROI before making schema changes, and having efficient automated ways to handle those migrations when they are needed. And yeah, a feature store can definitely help here too by standardizing features and putting a stable layer between the raw data and the models. It really boils down to finding that sweet spot, right? Where continuous improvement doesn't just lead to constant instability.
Okay, finally, let's tackle selection bias. This is a topic that can easily trip up even really experienced AI researchers. It can lead to models that just don't work like you expect them to out in the real world. The lyrics describe it powerfully. A tangled snare, caught in webs, we're unaware. Echoes of the lies we tell, they look new, but do they cast the truth in better light? It really gets at that fundamental question about the data we use and the stories it might be biased towards telling.
Yeah, selection bias is flagged as a critical core challenge in the sources, and for very good reason. At its heart, it's when the data you use to train your model isn't actually representative of the real world where the model will eventually operate. And it's not just about missing a few data points. It's about systematic exclusion or maybe overrepresentation of certain groups or certain situations. The song's image, Fractured Mirrors in Disguise, is perfect. It captures how this bias totally distorts the model's view of reality. It reflects a skewed picture, an incomplete one.
Like looking in a funhouse mirror and thinking it's real.
Exactly. And you end up with predictions that seem like they're based on real data, but as the song says, maybe it's real or just a shadow we can feel. This could be sampling bias. Maybe the data wasn't collected randomly. Or historical bias, the data reflects past societal prejudices.
Right.
Think about training a hiring model on old hiring data where historically certain groups were underrepresented or maybe unfairly assessed. The new model could just learn and perpetuate those same biases. Another tricky one is self-selection bias. The people who choose to use your specific product or service might not be typical of the broader audience you actually want to reach. So you end up thinking your model understands the truth, but really it's just learned the quirks and biases of your specific training data. It leaves developers feeling, like the song says, lost in matrix, chasing streams, waking up from dead dreams, when they realize their model fails spectacularly in the real world.
Wow. It's such a powerful reminder, isn't it?
Right.
Our models are only ever as good as the data we give them. If that data is skewed or incomplete or collected in a biased way, the AI carries those biases forward, and it can end up making flawed decisions, maybe perpetuating inequality or just completely failing to deliver what it was supposed to do. So what are the concrete steps? How do you identify this? How do you mitigate it? Especially when the biases can be so subtle, so hidden.
Yeah, identifying and mitigating selection bias is, well, it's an ongoing challenge. It's difficult, but absolutely crucial. It really has to start with meticulous data exploration. Visualizing the data, looking for weird distributions or discrepancies across different subgroups you care about. Then there are techniques like stratified sampling to make sure your training data set is representative, or reweighting data points to give more importance to underrepresented groups. Sometimes teams even generate synthetic data to try and balance things out. And for more complex cases, there are specific fairness metrics you can track, and even debiasing algorithms that try to adjust the model's outputs during or after training. But honestly, a huge part of it is having a diverse team working on the problem. People with different backgrounds are more likely to spot biases that others might miss. And it requires continuous monitoring, too. Checking that new data coming in isn't reintroducing old biases or creating entirely new ones. It's a battle that needs constant vigilance.
Wow, what a journey through data drift and destiny. I mean, from that relentless cycle we're in, to the slippery nature of ephemeral IDs, shifting sands, then that heart-stopping moment in My Experiment Broke the Site, the seemingly endless tweaks of one more table, and that insidious trap of selection biases. These songs, they really capture both the human struggles and the technical hurdles behind building this cutting-edge AI. It feels like an album that would really resonate with anyone working in this space. It offers, I don't know, both commiseration and some critical insights.
Absolutely. And these challenges, they aren't just footnotes, right? They're not minor technical details. They are absolutely fundamental to that pursuit of impactful, reliable AI solutions. Like this album, in its own really unique way, just reminds us of the resilience needed, the persistence, the critical thinking you have to navigate this incredibly complex landscape of AI development. It really underscores that AI isn't just about the cool algorithms. It's deeply tied up with data integrity, operational stability, and human responsibility.
And it definitely leaves us with a pretty big question to chew on, doesn't it? As AI keeps evolving, keeps getting woven into our lives, and we're constantly wrestling with these fundamental challenges. How much of its ultimate destiny is really down to the raw data we feed it? And how much is determined by our human capacity? You know, our ingenuity, our foresight, our sheer persistence, our ability to understand these problems, address them, and hopefully overcome them. It really feels like a dynamic partnership. Well, that's all the time we have for this particular deep dive into data drift and destiny. Thank you so much for joining us on this exploration. Until next time, keep learning, keep questioning, and keep exploring.